Alrighty, so like I said, today we're going to be talking again about equivalent ratios, but we're going to be looking at them in tables. So let's take a look at our example 1. It says to make paper mache, the art teacher mixes flour and water. For every 2 cups of water, she needs to mix in 3 cups of flour to make the paste. This is to find equivalent ratios for the ratio relationship of 2 cups of water to 3 cups of flour, and to represent them in the table below. So let's start by showing our kind of standard ratio. So our 2 cups of water, oops, let me make this a little smaller, our 2 cups of water to 3 cups of flour. So this ratio would be equal to 2 to 3. Remember, when we are making equivalent ratios, if we multiply both numbers by the same number, then we're getting an equivalent ratio. So if we multiply both of these numbers by 2, 2 times 2 gives us 4, 3 times 3 gives us 6. This ratio is equivalent to 2 to 3. I want you to fill in the last 3 spaces. You can continue that pattern and multiply by 2, or you can use kind of any pattern or any numbers that you want. I'll give you about a minute or so. I want you to fill in those last 3 ratios. Make sure that they are equivalent to 2 to 3. And then I'll take 3, we'll have 3 people share a ratio. Awesome. Jake, hold on to it for just a second, okay? Thank you, Mr. Aiden. Hold on to him for just a second, okay? We're just going to give everyone a minute to write those down. All right. Jake, give me one of your equivalent ratios.
10 to 15.
10 to 15. Very good. 10 cups of water, you'd need 15 cups of flour. Very good. We can check that because 2 times 5 gives us 10, 3 times 5 gives us 15. We multiplied both of those by the same number. Mr. Aiden, give me another one.
6 and 9.
6 to 9. Very good. 6 cups of water, 9 cups of flour. And one more, Austin.
8 to 12.
8 to 12. Very good. 8 cups of water to 12 cups of flour. All of these ratios are equivalent to 2 to 3. All right, all of them are equivalent to 2 to 3. Awesome job. All right, let's take a look at our next example. So our next example says Javier has a new job designing websites. He is paid at a rate of $700 for every 3 pages of web content that he builds. Create a ratio table to show the total amount of money Javier has earned in ratio to the number of pages he's built. So our kind of starting ratio is for every 3 pages, he gets $700. So if we multiply both of those by 2 again, for every 6 pages of content he creates, he gets $1,400. If we multiply that again, or if we multiply our original ratio 3 to 700 by 3, then we get 9 pages for $2,100. I'll do one more and then I'll let you guys do the last 4 on your own. For every 12 pages he creates, if he makes 12 pages, he gets $2,800. go ahead and fill in the last 4. You can kind of see a pattern here too. Once you've filled in those last 4, take a look at that last question. It says that Javier is saving up to purchase a used car that costs $4,200. How many web pages will Javier need to build before he can pay for the car? So once you've filled in the rest of that ratio table, go ahead and answer that question. Awesome, Jake. Thank you. Alrighty, so I'm going to continue with this pattern. So if Javier builds 15 web pages, how much money will he make? Anybody tell me that? Mr. Aiden, how much money will he make?
$3,500.
Very good, $3,500. If we continue that pattern, if he makes 18 web pages, how much money is he going to earn then? Jake, how much money will he earn for 18 web pages?
$4,200.
$4,200. If we continue that pattern, 21 web pages will earn him how much money? How much will he get for 21 web pages? Austin, what do you think?
Sorry.
Okay.
4,900.
4,900. Awesome. And I see Layla's agreeing with you in the chat. Very good. And our last number that we're going to look at, if we continue our pattern, is 24. Thank you, Layla. Layla says $5,600. If we answer our last question, Javier is saving up to purchase that used car for $4,200. He'll need to create 18 web pages. Right, because we see on our table, once he gets to 18, then he makes $4,200. All right, let's take a look at exercise 1. So exercise 1, I'll kind of start off for us, but then I want y'all to kind of work the rest of it out on your own. I'll give you a couple of minutes to do that. Or actually, it is 9:39. No, we have time. Sorry, I was getting off on my time. So exercise 1 says spraying plants with cornmeal juice is a natural way to prevent fungal growth on plants. It is made by soaking cornmeal in water, using 2 cups of cornmeal for every 9 gallons of water. Complete the ratio table and answer the questions that follow. So for every 2 cups of cornmeal, we need 9 gallons of water. So I want you to fill in the rest of that chart. And I want you to follow that pattern, okay? I want you to stay following that pattern. So just multiply by 2, add 1 onto it every time. And then answer the last 3 questions. So A is asking how many cups should be added to 45 gallons. B says Paul only has 8 cups of cornmeal. How many gallons of water should he add? And C is asking, what can you say about the values in the ratio table? Awesome. Thank you, Jake. Just hang out for just a minute. Oh, you still have C? Okay. Go ahead and answer that then. once you've at least filled out your ratio table, so the last 4 ratios, you can just type done into the chat. Just let me know that you're done with that. So once we're all done with that table, then we can start talking about the questions. So if you've finished these, just type done into the chat. You can continue working on the questions because I'll wait until everyone's done with the table. And then we can start talking about it. Awesome. Thank you, Jake. Thank you, Austin. Thank you, Layla. Thank you, Mr. Aiden. Thank you, Luca. Adrian and Genesis, I'll give y'all another maybe minute or two, and then we'll start talking about these. If you've already finished the table and the questions, I want you to take a look at exercise 2 and try exercise 2. And in about a minute or two, we will switch over. We'll look at this. Awesome. Thank you, Adrian. Thank you, Genesis. Awesome. Okay, so let's take a look at this really quick. So if we continue on with our ratio table, if we keep going with this pattern, our cups of cornmeal are going to go 2, 4, 6, 8, and 10. And if we continue on with these the gallons of water, we have 18, 27, 36, and 45. So A is asking how many cups of cornmeal should be added to 45 gallons of water. If we look back at our table, we see 10 cups. Part B says that Paul only has 8 cups of cornmeal. How many gallons of water should he add? If we go to 8 cups of cornmeal, we have 36 gallons. And what can we say about all of these values in the ratio table? What kind of generalization can we make? Jake, what could we say about all of these?
They're all multiples of 9.
Right, the gallons are all multiples of 9. The cups of cornmeal are all multiples of 2, absolutely. Another thing that we can also say is that these are all equivalent ratios, right? If we write all of these out as a ratio, they are all equivalent to the ratio of 2 to 9. So that's something else that we can say, they're equivalent. We could say that there's a pattern. There's a lot of different things that we could say about these ratios. So you can kind of choose what you want to say. All right, we're going to spend the last couple of minutes looking at exercise 2, and I'll give you the last couple of minutes to go through exercise 2. So James is setting up a fish tank. He is buying a breed of goldfish that typically grows 12 inches long. It is recommended that there be 1 gallon of water for every inch of fish length in the tank. What is the recommended ratio of gallons of water to fully grown goldfish in the tank? So if we start, let me get to my page. So if we assume that we have all full grown goldfish, our starting ratio, exactly, Jake, thank you. For 1 fish, we need 12 gallons of water. So we need 1 gallon for every inch of the fish. So continue with that ratio or with that table and then answer those 3 questions. Hold on, Mr. Aiden. We'll wait for just a minute. We'll let everybody get there and then we'll talk about it. Awesome, Jake. Did you do A, B, and C? Okay, cool. Just hang out for a minute. We'll talk about it in a minute. Thank you, Austin. All right, since we are almost out of time, let's start looking at this. So who can tell me if we have 2 fish, how many gallons of water are we going to need? For 2 fish, how many gallons do we need? Yes, Aiden, you need to answer the question for C, just like we did for C before. I just didn't write it down because we had a lot of answers. Thank you, Adrian. We need 24 gallons of water. What if we have 3 fish? Austin, how many gallons do we need?
We need 36 gallons.
36 gallons. Awesome. And if we have 4 fully grown goldfish, how many gallons do we need? Who can tell me? Jake, how many gallons do we need?
48.
Very good. And if we have 5 fully grown goldfish, how many gallons do we need? Thank you, Layla. Layla says 60. Awesome. So A, what size tank in gallons is needed for James to have 5 fully grown goldfish? If we look at our table, it's that last one, 60 gallons. Needs a 60-gallon goldfish tank. B, how many fully grown goldfish can go in a 40-gallon tank? So if James has a 40-gallon tank, how many goldfish can he have in there? Who can tell me that? Mr. Aiden, how many fish can he have in a 40-gallon tank?
3 fish.
Absolutely. And I see Adrian is agreeing with you in the chat. Perfect. He can have 3 fish. Even though for 3 fish, you only need 36 gallons. You can't have any more than that because if you had any more than that, you would need more space. So he can only have 3 fish. And then for C, what can we say about the values of these ratios? Kind of the same thing that we said in the previous question. They're all equivalent ratios. There's a pattern. You can kind of choose what you want to say. That our number of fish, as our number in fish increases, our gallons of water increases, our gallons are multiples of 12, things like that. Okay. All righty. So let's very quickly take a look at independent practice. For independent practice, you have 3 ratio tables to fill in. So you're assuming that each of the following tables represents a table of equivalent ratios, and you're filling in the missing values. And then you need to choose one of the ratios, so one of the tables, create a real world context for the ratios that are being shown. So for example, you could have fish tanks, or you could use a recipe or something like that, okay? You're gonna make up your own kind of real world scenario where you might need this ratio table. You'll notice that the first row is blank in each of these tables. So this is where I want you to put like the unit ratio. So the smallest form of the ratio, right? So in our guided practice, our first ratio for exercise 1 was 2 to 9. We couldn't get any smaller than that. Well, we could, but that was where our problem started. For exercise 2, we started with 1 to 12, right? So that's where we're kind of starting. So I want you to make sure that your first ratio is kind of the smallest form that you can have if possible, okay? And And very quickly, I have a secret word for you. Our secret word today is our last Thanksgiving word. It does have to do with turkey because it is something that you do to your turkey after you finish cooking it. And that is carve. You carve your turkey. Alrighty, so please make sure that you have that written down somewhere.